Assalamualaikum and hello everyone. Today our group will be presenting on chloromethane, which is an organic compound from the alkyl halides class. So right now, my name is Damiana Patricia. I would like to introduce all my creative friends, which is Nur Khairul Suraya, Nur Ain Suraya and Wan Putri Nurin Adlina. And right now, I will start presenting first. Chloromethane is an organic compound that belongs to the alkyl halides group. It is one of the simplest members of the haloalkane family. This compound is made up of only three elements, which are carbon, hydrogen and chlorine. Despite its simple structure, chloromethane plays a significant role in organic chemistry and industrial applications, which made it an important compound to study and understand. As shown on the slide, the compound we are focusing on is chloromethane. Firstly, let us look at the molecular formula of chloromethane. The molecular formula of chloromethane is CH3Cl. According to the IUPAC naming system, it is called chloromethane, but it is also commonly known as methyl chloride. This formula shows that chloromethane is made up of one carbon atom, 3 hydrogen atoms and 1 chlorine atoms. From this, we can identify the type of compound and predict its chemical behavior. Next, we move on to the molecular structure and bonding of chloromethane. Structurally, chloromethane consists of one carbon atom bonded to 3 hydrogen atoms and 1 chlorine atom. The carbon atom forms 4 single covalent bonds, giving the molecule a tetrahedral shape. An important feature is the carbon-chlorine bond. Chlorine is more electronegative than carbon, so this bond is polar. This polarity affects how chloromethane reacts, especially in substitution reaction typical of haloalkanes. Now, let us discuss the physical properties of chloromethane. In terms of physical properties, chloromethane is a colorless gas with a faintly sweet smell. It has a low boiling point of -24 degrees Celsius, which is why it exists as a gas at room temperature. It is also slightly soluble in water, as the molecule is mostly non-polar despite having a polar bond.
Chloromethane or CH3Cl is an important organic compound widely used in industry. It can be synthesized by reacting methane with chlorine under UV light through a process called free radical substitution. In this reaction, UV light breaks chlorine molecules into highly reactive chlorine radicals, which then replace a hydrogen atom in methane. This produced chloromethane and hydrogen chloride as shown in the chemical equation. Carefully control of reaction condition is necessary to avoid further substitution, which can form other chlorinated compound like dichloromethane. Industrially, chloromethane is mainly used in the production of silicone, which are essential in lubricants, adhesives, sealants, and medical devices. It also used as solvent and starting material of various pharmaceuticals and organic chemicals. Furthermore, for the next slide, it is natural sources for chloromethane. Interestingly, chloromethane also occurs naturally in the environment. The ocean are its largest natural source, where marine algae and microorganisms release chloromethane through their biological processes. On land, it is produced by fungi, bacteria and the decomposition of plant material, where organic matter interact with naturally occurring chlorine compound. In addition, natural events like forest fires and volcanic eruption release chloromethane into the atmosphere. This natural source, together with human-made production, contribute to its presence in the environment and play a role in atmospheric chemistry. Overall, chloromethane is a simple but highly versatile compound, valuable both in industrial application and its understanding natural chemical cycles.
Next, I will explain the reaction and chemical behavior of chloromethane, focusing on the SN2 nucleophilic substitution reaction. SN2 stands for substitution nucleophilic bimolecular. This reaction happens in one step where a nucleophile directly attacks the carbon atom that is bonded to chlorine. the nucleophile attacks from the opposite side of the leaving group, which is chlorine. As a result, the chlorine atom leaves at the same time the nucleophile attached to the carbon. This reaction occurs easily in chloromethane because it is a primary alkyl halide and has a small molecular size which allows easy backside attack. Due to this backside attack, the reaction causes inversion of configuration, also known as Walden inversion. For example, when chloromethane reacts with hydroxide ion, the chlorine atom is replaced by the OH group, forming methanol and a chlorine ion. Now, I will move on to a special reaction of chloromethane, which is the Grignard reaction. Chloromethane reacts with magnesium metal in dry ether to form a Grignard reagent known as methyl magnesium chloride. In this reaction, magnesium inserts itself between the carbon and chlorine bond. This makes the carbon atom partially negative, which allows the Grignard reagent to act as a strong nucleophile. Grignard reagents are very important in organic chemistry because they are used to form carbon-to-carbon bonds. However, this reaction must be carried out under anhydrous condition, meaning no water is allowed. This is because water can destroy the Grignard reagent. Chloromethane reacts more easily compared to larger alkyl halides because its small size allows easier reaction with magnesium.
Hello, now I will talk about the practical application of chloromethane. Chloromethane is widely used in industry and chemical manufacturing. One of its main use is the production of silicone polymers. These silicone materials are used in sealant, medical products, and personal care items. Chloromethane also used to produce methyl cellulose, which is found in food products, pharmaceutical tablet, and construction material. In addition, chloromethane is used in organic synthesis to make other useful chemicals. In the past, it was used as refrigerant, but this use has been reduced due to safety concerns. Next, I will talk about the environmental and health impact. Although chloromethane is useful, it can be harmful if it not handled properly. Breathing in high concentration of chloromethane can cause dizziness, headache, and nausea. This is happen because it affects the central nervous system. Chloromethane is also a flammable gas, so it must be stored and handled carefully. From an environmental perspective, chloromethane has a small effect on the ozone layer, which is why its use is regulated. Next, to conclude, the chloromethane is a simple alkyl halide, but it has many important uses. Its polar carbon-chlorine bond allows it to undergo typical SN2 reaction. Chloromethane is produced both naturally and through industrial process. Fun fact, chloromethane is used in the production of silicone rubbers, which is found in medical implants and baking tools. The other fun fact is natural sources such as plants and oceans release more chloromethane than human activities. Interesting, right? I think that's all for now. Thank you.